This is the second breakout session for the new CEDAR Grand Challenge, which is focused on pathways to improve space weather predictability. And this is the format we're going to go through. So similar to the morning session, we'll have a panel discussion. And the panel discussion in the afternoon is focused on cross-sector, cross-organization perspectives and collaboration. Then during that panel conversation, we'll have dedicated, moderated parts of Q&A, but then we'll open it up to audience towards the end as well. And then we'll move on to these small group conversations where you get to talk a little bit more about the topics, especially relay races and batons, that Lynn would talk more about it. I'm not going to get into it too much. And we'll end with closing remarks and next steps by Yaga, because these two sessions have really been more about introducing the Grand Challenge, getting your feedback, and we want to go from these high-level science questions to more refined and think about what could be outcomes, actionable outcomes coming out of this Grand Challenge. And so Yaga will talk a little bit more about the process of how we're going to do that. And with that, I'm going to pass it to Lynn, who's going to moderate this session, and she'll invite the panel on stage. Thanks, Lynn.
Hey, everybody. Welcome, and thanks for joining the cross-sector panel on pathways to improve space weather predictability. I'm Lynn Harvey, and I'll be moderating the panel Q&A. Space weather predictability is not something any single sector can solve alone. It requires sustained coordination among academia, government agencies, national labs, operational centers, industry, and the user communities that depend on these products. The goal of this session is to step back from any one contributor or aspect and look at the full operational data pipeline, from observations to data systems, numerical models, forecasts, operational systems, and ultimately the end users. So when I was out on a walk thinking about this session, I thought of a relay race where we've got all these different runners and they need something from each other. They have to pass a baton to each other. So I'd like to think about the pipeline as a connected system. In formulating this session, we thought of the operational pipeline as a relay race, and here we will identify who are the runners, what are the batons, where are the handoffs working well, and where do they break down. We hope an outcome is to identify potential improvements to help us move toward more reliable, actionable space weather prediction. So before our panel discussion, each panelist will share their perspective of the pipeline for 2 to 3 minutes. First, with Rebecca Bishop at Aerospace Corp speaking on the details of the operational pipeline.
Thank you. So what I wanted to do was to, all of us are used to being considered a scientist. Well, there are different types of scientists. And the way the environment is going with funding and focus, we really need to characterize the different roles as scientists that we are going to play. And so on this right here, do I get to, does this, yes, oh, no, back. All right, yeah, forward. Okay, got it. As a scientist, you can either be a traditional scientist, which is traditionally what CEDAR actually works on. We all do our own case studies, we work theory, we do new tools, new algorithms, we do a fundamental understanding, and then you go and you actually do an applied scientist, or you apply that knowledge to a problem. And then from there, you go up into more of an operational or a transitional scientist, where you take the knowledge that you gain doing the foundational work and you transition that into something that is usable for the end user. And then at the very top there, you will see you have the operational system. And so at that point, you need a scientist as part of the team, so they actually apply the environmental knowledge appropriately to their system, and that it's actually integrated. And you'll note that I actually did this on purpose as far as building this from a traditional scientist on the bottom, because that's where you're going to have a lot of information, and as you go upward, it slowly filters out per application. Traditional scientist does fundamental understanding. Applied scientists, you're doing a focus on quantifiable improvements. Transitional scientists, you operationalize it so it's actually useful. And then the operational scientist, system scientist, you are actually integrating into a end user system. And this is also, you can see the R2O to R flow here, where upward is really the research to operations, and then the downward flow in the colored arrows is the O2R. So we'll just do that. So as far as myself and at aerospace, aerospace is involved in all four aspects. We actually supply scientists working as a traditional scientist, applied, transitional, and as part of the development team for an operating system as an integration scientist. Myself transitional scientists, 30% about on applied, and about 15 on traditional, and 5. Now that changes, and I also want to point out, moving through an operational system or making this operational, there are different skills needed for each one of these type of scientists. And someone who is a traditional scientist shouldn't necessarily be a PI of an applied science project, but they should have the traditional scientists as part of their team. As well as the reverse. When you're doing traditional science, it would be great to make sure that you have an applied scientist or someone who is familiar with the transitional part as part of your team going forward. So if you look at the green part, which is the operational systems, what does that entail? How do you get your environmental tools or your environmental knowledge into your operational system? And so this is kind of a very notional pipeline. This is very simplistic. This is almost very linear. Most operational systems are not linear. And so I just want to note that for every application, you would have a much more complicated, complex operational data pipeline. You start out with the observations, which from individual sensors, missions, and so forth. We call those sensor data records. You process those sensor data records somehow, either through models or algorithms, AIs, whatever, to produce environmental data records. Those are done at some sort of production place, and then they get put into forecasts, and then both the EDRs as well as your forecasts are used inside the operational system, either to inform ConOps or are actually integrated into the system. The thing to note is the various users, your research, your public, your commercial, your government agencies, they may and often access the data throughout this pipeline. But the ultimate goal is the operational system, and that's where the end users exist. And so as we go forward and we're talking about examples of sectors, these are just a list of some of those: academia, civil government, FFRDCs, UARTs, national labs, Defense Department, and so forth. And with that, I'll turn it over to the next speaker.
Okay. Please have a seat in our panel. All right, I'd like to invite Anastasia Newhart to the stage from SWPC.
Okay, perfect, thanks. Hi, everyone. My name is Anastasia Newhart. I'm a research scientist at NOAA SWPC. And I guess to show where I fit into Rebecca's flow chart here, at SWPC, we're issuing forecasts, space weather forecasts for the United States, and we collaborate with other offices in other countries that also issue space weather forecasts. So we're doing the role of taking models and transitioning them into an operational product. So as transitional scientists here, and of maintaining the operational system. So we also have a large technology division that does a lot of that, but of course the scientists help with that too to make sure models are performing as we expect. So SWPC's goal is safeguarding society with actionable space weather information, and these are the priorities that we've identified for research to operations collaboration with the larger community. So these are validation and verification capability, advanced predictive skill, translating forecasts into end user risk, and then actually operationalizing what works together. So these are pretty big, sort of, I would say high-level topics, and they could fit into a lot of different projects and a lot of different topics. Particularly since SWPC doesn't just focus on ionosphere, upper atmosphere, I would say their primary focus is actually more on solar physics and looking at the propagation of CMEs and the effect of geomagnetic storms. So here are just a couple examples of what this could look like for each aspect of collaboration with the research community. And I've just taken a couple of these and just sort of highlighted which ones I think are most relevant for the CEDAR community. So validation and verification has been a big topic for us at SWPC. And so what that could look like would be something like uncertainty quantification for some of the existing ionosphere models that we have. Or, as well as for the thermosphere and satellite drag. So in terms of advancing predictive skill, currently most of SWPC's actual forecast products are more related to the solar side, but this could still fit into the ionosphere side by advancing the predictive skill of the few ionosphere and upper atmosphere models that SWPC does use. I would say the biggest opportunity that this community has for working with SWPC in terms of research is this category here, translating forecasts into end user risks. Since the ionosphere and thermosphere are a big, very large, complicated, coupled system, I think we have a lot of opportunity to focus in on the most operationally relevant end user risks. So HF communication, GPS, satellite drag, getting all of these risks quantified with real-time ionosphere and thermosphere measurements is a big opportunity and something that we're really interested in pursuing at SWPC. The other aspect of operationalizing tools is sort of the collaboration aspect. Working with SWPC so that we can understand, or so that the research community can understand how the model will be used either by the forecasters or by end users, and understanding what needs to be implemented in order for it to be an operational tool. So oftentimes this is where scientific programmers come in and can sort of help get that real-time pipeline ready so that the tool can be used in that way. Thanks.
Great, thank you. Next, we'll hear from Wei Xiao from NRL.
Thank you. Hi, everyone. My name is Hui Shao. I'm working at NRL. And as I mentioned earlier this morning, I'm only sitting at NRL for 1 month. And I was a UCAR person. So I do have my colleague. They are more experienced and qualified for this panelist. But on the other hand, I think I probably have a little different community aspect looking at NRL. So talking with my people at NRL, we figured most of us, at least the team we are working modeling and data simulation teams, we are fall into the transitional scientist and applied scientist. Myself, I'm more data simulation person, but of course we are also tasked to help with operations. And I also have some fundamental scientists doing the fundamental science, traditional scientists, and we also have people working with development team. They are not the majority, but we do have people working on those 2 areas. So, and I feel like it's good to let people know what NRL are doing. We are working on operational system. You can see there are 2 sides. One is thermosphere, the other one is ionosphere. And I also have the NWP components. So basically, we are working from bottom to top. We have different models, NWP model. And you can see the right bar is more indicating going up, and it goes to the Neptune and the Neptune. You have heard those terms, probably more than me. And on the other side, we also have narrow semi down the road for the ionosphere models and data simulation. So I want to highlight is the color bar here showing the availability for the observations toward operations. And you can see the yellow font indicate they are operational available. And anything with highlights in the color box, they are indicating they are not available in operational sense. And unfortunately, there's almost nothing for thermosphere in the operational data stream. And we are still using that for research or doing validations, but I do think there is a big gap just in terms of observations. And we have limited observations, but at least we have operational data for the ionosphere. Okay, bear that in your mind. What we are doing, especially my team, we are doing data simulation. We are trying to have two parallel work efforts. One is from bottom to top. We are simulating data for thermosphere, but we are having the model coming from the NWP extended to the 150 and the MA, and go to even higher to the high atmosphere. And so again, this is thermosphere data simulation, but we try to add ionosphere for this system so we can understand how it works between thermosphere, ionosphere data simulation. On the other side, we have our own ionosphere model and data simulation, and we are simulating from that area, and eventually our goal is to have fully coupled data simulation, and in the future is a full coupled data model. So that's the ongoing, very active work. And how to do that is, one way is, I mentioned CEDAR here, it's probably new to this community. That's a system already being adopted by NLP by different centers. And we are trying to use one data simulation system for all the atmosphere. And we are hoping that will provide a coherent system to integrate the data. So next one. Just considering what we are contributing to the community and what the community might help us, we are delivering operational capabilities, and we are now working with CEDAR, for example, or other systems so that we can provide capability to the community. You can see what's going on from the proxy. We have PyRI, HWM, MSys, all going to CEDAR repository. And of course, we are looking for fundamental research. We need observations. We need simulation studies. We need to share observation, open infrastructure. And a lot of fundamental science will come from this community. And definitely, we would like to work with you guys. And eventually, we can transition the research to operations. That's it. Thank you.
Thank you. And finally, we will hear from Federico Gasparini, who will provide an industry perspective.
Great. Well, thank you, Lynn. I'll start by briefly introducing myself. I know several of you probably already know me, but my background really is in ionosphere and thermospheric science, with a focus on variability, the propagation of waves, coupling, as well as electrodynamics and space weather processes in broader terms. That is the traditional scientist piece that I've highlighted there, so building sort of physical understanding of the system. But in my current industry role, I joined a private company from Anchor about 6 years ago, and I, more recently transitioned actively into more of the transitional scientist and applied scientist role. And I spent a lot of time in that role really in the, taking really science results, models of, physics-based models and empirical models, and observations and, mission concepts, really asking how they can contribute in a measurable way to operational community, in particular to customers that then we, as part of the industry, are able to, sell products eventually too. So the perspective I want to bring in today is really that in that research to operation pipeline is just really not model handoff, but it's a full system, approach where, that includes, and I'll mention that in more detail later, the importance of validation, uncertainty, and I think Anna earlier alluded to that on, from the SWPC perspective. Uncertainties are really critical in this process, and I think we also heard about that earlier today, and on requirements, user needs, and operational constraints as well. So this slide really gives a concrete example of the approach in industry where we're taking research really to operations. That's a system that I'm bringing here to your attention is TIBIT, that has been developed at Orion really since the times of Jeff Crowley. And then that has been then made into a more applied system now called Trident that has been deployed. And what that really does is TIBIT is in NHF Doppler capability. And so it really does detect and characterize travellic ionospheric disturbances, or TIDs, in particular in looking at their period, speed, direction, and related structure. And we have done, the scientists in our team have done work on improving the modeling of those. But then the critical piece there is that, as I'm showing on in the photo in the middle, we have done field sensing of that system, and then created data products that we are able to sell. So really the key point here is the flow of the slide really is starting from physics, such as waves, TIDs, and in general ionospheric variability, moving to the right, that inform the sensing approach, so where to measure, what to measure really, and the signatures that need to be detected. And then the measurements that can become a useful data product that eventually has, a customer, and the customer really will be interested in on uncertainties, latency, false alarm behavior, and a number of other things that should be included in that data product. So very briefly, so from my perspective, transition is not only handing off the model, but also to provide data quality and uncertainties associated with that is enabling a user to make decisions, and that's what generally gets requested often from a user perspective. So finally, this slide just gets at what I think is one of the most important things in the R2O pipeline, that is shared validation infrastructure. I highlighted that in the bottom right. Which, from an industry perspective, we can contribute really persistent observations, such as what we are doing with the Trident system, and deployable regional test beds, also event catalogs, null cases, and performance metrics. But for that really to be useful, we need the broader community to also help us understand what that means in terms of their own needs, and I think open data sets and certain aware validation standards are very important in that. And so the main point is that really prediction, does not improve only by studying more events. We have seen a lot of studies, for example, on the recent storms, at least, the ones that, the large ones in the last solar cycle. But really to become that, useful to the user community, we need to have a better understanding on, how that translates into metrics, and in particular the importance of those common metrics. So often, the industry speaks a different language to what's spoken in the research community. We need to do a better job at sort of closing the loop in that regard. That wraps up my presentation.
Okay, please have a seat on our panel. Thank you to all of our panelists for that introduction. Now we'll go into the moderated Q&A part of the panel. And we've got 3 questions for our 4 panelists, and they've all been advised to answer in 2 minutes, which means this part is about 24 minutes, give or take. I will signal 2 minutes, meaning wrap it up if you're still making points, but I don't want to rush things along too much. And then after the Q&A here, we'll have discussions at the round tables. Here we've got questions formulated for you. So without further ado, our first question, from your perspective, what is the weakest leg of the research to operations relay currently? Rebecca, you want to kick us off?
There we go. Okay. So I'm going to say it's not even the leg. I'm going to say it's the race, in the way that the weakest part is that we don't scope or define the race well. We take too big of a pieces and try to tackle that. And what I mean by that is you go by either an end user need or a specific space weather structure event sort of thing and work that way rather than trying to just improve predictability across the board. Within that, I would say really the weakest leg is, and we've heard this over and over again, quantifying the errors, defining reasonable or relatable or usable products to the end user. We have a lot of great work, but showing its relationship or how it benefits the end user is really the weakest part.
Okay, thank you.
Oh, well, I definitely agree with what Rebecca just said, but I guess I would also say that, I guess in my view, it's kind of going from the applied research to the operational product. Like, for example, like there are many good models that could be set up to run real time, but then if that hasn't been the focus in the research project, it would take a lot of time for people to do that and might need particularly specialized software expertise. The other thing is that if a product or a model or a data set was sort of developed with this research goal in mind, it might not really be aligned with SWPC's goals or SWPC's specific operational needs. The other thing, I guess, maybe this is more my personal pet peeve, but there are many data sets that would be really, really good to use but are not available real time. But again, that presents a really large infrastructure problem. So we need to be able to set up the infrastructure and also then, of course, do the validation so we can actually use that product and understand when is it going to work, when is it not going to work. But I think that oftentimes this ends up being sort of a gap in all of these, a gap in the our relay race, since there's kind of 2 different mindsets that are happening there.
All right, when I talked with my colleague at NIL, and we finally came back with the word for operational forward thinking. And we believe that, we really want to get the research to operations, but then there's difficulty to transition the research to operations because a lot of, like Anna mentioned, that the model, for example, is too bunky to run in operations. Observations not, as mentioned, not available in terms of the pipeline. Latency is a problem. So I think it seems some science, for example, we are only using F10.7 as the forcing. But I believe there's research probably going to look at different forcing or how to use that in the model. They should be transitioned or can be used in operational models, but with certain lack of that, that bridge. So definitely forward thinking in terms of operations is a keyword to us.
Yeah, and from my perspective, I would say, and I think I talked a little bit about this earlier, and I think Anna and Rebecca also mentioned that. But really, the transition from validation layer, from good science and operational trusted capabilities is difficult often because we don't have the common metrics or validation schemes for in general, like we are not talking often the same language. So for our work to really be impactful, of course, we also have to be able to look back from operations to research and know what is an end user's need in a particular case. And often we're evaluating different different events as sort of case studies, but we really lack that common metrics and common validation approach, which I think would make it a lot easier. And I can only think about some exceptions in that regard when you're thinking about R2O, 2R, sort of programs that have attempted to tackle that particular challenge, but has not really led to, if you're talking at least to some of the funding agencies, has not always led to very useful, outcomes. So I think, it's a big challenge there, but ultimately I'll just say that a lot of at least the private sector wants to, sell eventually their products, and there can be, big issues in translating back their operations into the research piece. And so, that miscommunication is due to different background between researchers and maybe users, but then also in terms of, proprietary information that cannot be shared easily back. And that involves national labs as well, but, obviously if you're in the private sector, that becomes even more of a challenge.
Thank you all, and I encourage you as you listen to our panelists' responses to think of questions to ask them. Before we go into our group discussion phase, we're going to have a 15-minute Q&A, so hopefully it's not crickets. You're going to be thinking of really good questions to pepper our panelists with. All right, so question number 2, given your position in the pipeline, what do you need from other sectors to do your role well? As in, what batons are you handing off, and what batons do you need to receive? Rebecca?
So there's a lot of different ways of answering this question. In the pipeline, you need the right skill set of people working at the right point in the pipeline, and that's something we don't have. We have a lot of people who know how to do the foundational science. We know how to communicate that. We have a few that can do the applied science, but we don't have enough people that know how to do the transitional science. And what we really need is the right mixture of people working together, because often you have transitional scientists trying to be a foundational science. They're going back and trying to understand what all the studies that have been done and what's the best thing to use. You have people who are traditionally doing, CEDAR science, but that now are asked to try to communicate or set up projects that will transition to operations. So it's really about getting the right people at the right place, working together. Once we have that, I think a lot of the needs, like the errors and the improved products or different tailored products, all that will come, but you have to have the right runners on a team.
That's a really good point. I had not actually thought of it like that. So I would say, I guess, SWPC is very focused on providing, space weather forecasts and specifically for our users. So one thing we need is information about what is useful for us to provide. So even though SWPC is certainly focused on providing forecasts for say the power grid sector or for aviation, but the research community is also priorities. So we want to get feedback from the research community about how you all use our models, how you all use the data we provide, and any feedback you guys have on our models. If there's any suggestions you have, things like that. I will say, so that when researchers are collaborating with SWPC, I think something that's really important, and something that I would not have thought of before I worked here myself, was that researchers need to engage with SWPC very early in the process so that they can understand kind of how the tool would be used. Especially so that the forecasters can give input. Since our space weather forecasters, many of them have a space physics background, but they probably, I don't think any of them have specifically ionosphere background. Do you know what I'm saying? So they have space weather expertise, but it's much broader than the specific expertise that you have after you've developed your model and your tool. So when you're making that tool, you kind of need to keep that in mind and probably have had the conversation with them beforehand. Since they probably don't have a lot of expertise about the ionosphere or atmospheric dynamics specifically, or that particular the way that particular model works, and also understand the way that they make decisions in real time. Since they have to issue alerts, they have to make decisions with limited information. And so just understanding, like, okay, if this is all the things they're looking at across their dashboard, like in their office, they have all of these screens. So if they pull that up on the screen, what are they going to compare it with? And how are they going to use that information to make a decision? So I think, that's it for me.
Okay, I really like to talk about, Rebecca mentioned about the right people at the right position. And I'm just saying that, do we have the platform to have do we really streamline the pipeline yet, right? I mean, I mentioned earlier, I don't see data people here, for example. And the first question as operational centers is, where are the data? We have to struggle to ask people to give us data. And if we are talking about position in the pipeline, we need to have pipeline first. And that's one big problem. We don't have a streamlined pipeline. So that's the first, things came to my mind is I think we need to get the right people, at least talking at the same time to each other. If we can have a proper platform, if this is the right one, we should invite different people coming from different sectors to talk to each other. And, in terms of the need, we need observations. We also need some scientific work ready for operations, like the forcing part I mentioned earlier. And how to facilitate such transition. I agree, earlier comment is, we probably need to talk with sponsor agencies to encourage this kind of operational forward thinking into their funding mechanisms, and encourage people to work with operational systems or centers to transition their research, directly talking to each other and transition the research from our scientists, rather than build a bridge in between and lack of the transition. So that's a couple points we talked about over NIL. That's it.
Yeah, thank you. I would say that, I'll probably reemphasize what I said earlier in terms of what researchers, can provide. That is, assumptions, the assumptions that have been made, in producing the data or the models that they're giving out in the system, the limitations, the uncertainty, and also validation cases that are important there. But then the operators and end users really should there should be a way for us to be able to incentivize them to then feed back into the loop so that they can provide information on what are they really trying to decide and how fast do they need the information and sort of what level of uncertainty is acceptable. So you can run the model and have some estimates of the uncertainties in data being collected in situ remotely and in space on the ground, but then you might not know what is the tolerable level and how that can be, used and be acceptable really for the end user. And also the false alarm rate is important. So if you have, there are studies that evaluate, for example, TIDs and try to predict them, or what feeds them. So an end user will also need to know, what how often false alarm, false detections would be occurring, because it has implications for I'm thinking about radio propagation, for example, on the ground. So that is very important, and also the spatial and temporal resolution does matter. I think we had some discussion this morning on the importance of and tendency of going towards high resolution models, for example, and the computational challenges of that, and whether those are important or not really does end up being something that the user needs to assess and be able to feedback information in that process. But then the industry really can provide a lot of additional resources when it comes down to data and deploy sensors, for example. Not always data. There can be challenges in the way that data can be shared from industry, but there is a whole set of data sets that are largely unutilized from industry that would be very, very important, tying back to, I think, to what I heard this morning from John McCormack related to the importance of neutral densities, for example, and how we could utilize a lot of satellite data that's already available for our own research, but we're not doing that, at least not to the extent that we should. So just a few remarks there.
All right. Our third question: what are the greatest needs of current operational infrastructure and/or end users related to information movement from researchers to operations, from operations to users, and from users back to researchers?
So I'm going to take a step back on this question. And really, I honestly think we need the definition of what the operational infrastructure is per application, because you can't decide where you have a problem if you don't know what the infrastructure is. What is it providing when? Who's providing what are the limitations? What are the interfaces? What's the real time? I'll take the neutral density for example. You have to understand how that neutral density is used by the orbital analysis, operational or orbit determination software. What they need, when they need it, what they pull in. They pull in both a nowcast, they pull in a precast, and they pull in a forecast. That's not something you think about. And so they need to know the errors on all of those things. And where they get those and how those are produced, there are weaknesses in that operational chain, let alone then how their results get used or fed back into the infrastructure and so forth. So I think the greatest need right now is a clear understanding by the scientific community, the traditional community, as well as the applied scientists and the transitionals of what individual pipelines are there, what ones don't exist, because why do research and improve on something where there is no pipeline to the end user? Maybe that's then you need to put the effort into creating that pipeline. So I think there's some larger fundamental issues than getting right into the individual data or information.
I guess I would say that in terms of kind of information movement, like step by step through the process, right now, at least at least at SWPC, we don't have, at least compared to some other topics like solar physics and stuff like that, we don't have that many operational products related to ionosphere and thermosphere. So I think we're kind of, in that way, still working on building out the steps in the pipeline. So we need data sets that are available real time so that we can use those and feed those into models. We need models that have been rigorously validated so we understand their constraints and in what context they work. And then we need to use those models to make forecasts and products that are focused on specific hazards. So GNSS disruption, HF communication disruption, thermospheric density and satellite drag, stuff like that. And then I guess in terms of sending the information back down the pipeline the other way, we at SWPC and with the end users, we need to make sure that we've communicated to everybody what the end user's needs are. Like, I know at least when I started working at SWPC just a few months ago, I was really surprised by some of the aviation-related concerns there were. Like, I didn't know that, I had thought that GPS would be the biggest thing they'd be the most concerned about. They're not very concerned about it. It's certainly something they need, but they have other backup systems they use as well. So I'm like, oh, okay, that was a big surprise to me. But that radiation is something that can impact the airlines a lot because, I mean, they have their staff there in the plane. And I was like, wow, I had never thought about that aspect of it. But of course, until you take the time to engage directly with the end users, which is like, I think often happens, for example, at Space Weather Workshop, you wouldn't know that. And even with the geoelectric grid, I was really surprised to hear that they, while they don't use GPS as much for the location precision, they do use it for timing. And so timing disruptions to GPS, honestly, I had never thought of that in my life. So like, how can we take the tools that we have and tailor that for them? And how can we take those needs and communicate that back to researchers so that they can take that into account and integrate that into the model? I think those are the current challenges.
So NRL has specific users, so of course it's a little bit hard to talk about how to transition that one, at least not for me to talk about it. But on the other hand, I do think from needs from the community, I mentioned a couple of things already. Observation pipeline, that's the greatest needs, especially in the operational term, right? The latency, etc. And the other one is the science can have more or less urgent to improve the current operational system. For example, the solar forcing, how to use it, or kind of models to use more complex solar forcing. That kind of research will be greatest needs right and now for the operational system at NRL. But on the other hand, how we can get back to like NRL is more closed door research, operational centers. We are thinking to open the door in a way that we are trying to use some community available systems so that we can show what we are doing, similar to what we are doing, so that we can provide our feedback to the researchers. I feel that the connection, the bridging between the operations like NRL and the research community, that's one of the greatest needs, is to build such a bridge. And it will help us to connect with community and also help us to broadcast what we have, the capabilities, what we have, and then you can benefit from our studies, our researches inside our house. I feel that might be something also for the community to need to know what we are doing. So that's our aspects.
Yeah, and I'll just add there that from my perspective, really that data movement is should be associated with the information movement. So what really is needed from the operational users for that for that data to be useful is, as we've discussed quite in detail, the need of uncertainties, and as well as how quickly that information was available, and what users should do differently because of it. But the other major need in the feedback is really in the opposite direction. How that information then translates back into researchers and system developers, I think, we discussed, how NRL might have issues in, pushing back information into, the research community. That is certainly, something that, also belongs to the, private space as well as, end users to some extent. But, we should be thinking about how we can change, that loop back. And I will just say, three things, at least, caught my attention there. The first is that the products, again, needs uncertainty and confidence built in it. And then for the operational infrastructure, we need common validation and benchmarking. That's what I've, said all throughout. I think it's very important so that the tools can also be compared. And then third, we need feedback loops that go from the users back to the operators, industry, and researchers. And the later part that is really non-trivial because of all the restrictions that might be in place. But I think it is an important thing to to think about and how we can from our perspective be able to contribute to improve that process, and not only as a CEDAR community but also as broader community members in the scientific community as well as just citizens. So we should think about ways that we are able to contribute back even as an end user to the research community, how their products are useful. And so it's a difficult thing to tackle, but I think it's an important one that we're facing, especially in the current funding regime where applied science and really transitional work is encouraged. And I will echo, I think, what Rebecca was saying in terms of the the challenges for the CEDAR community to be able to embrace that, since at its fundamental is really a fundamental science type of community, and we shouldn't be asking to everyone in the community to necessarily produce products, but at least it's important for them to understand the user needs so that they can provide value and also describe how their work is relevant to the broader society, I would say.
All right, that was great. Now it's time for you to ask our panelists some questions that may have come up as they've been talking about these things. Okay.
Working? Yes, it's working. So Tomoko asks, are there any recommendations to higher education regarding workforce development to fill in the gaps in the pipeline? Does the partnership between operationally oriented institutions and universities help train more future graduates with the right desirable skills? Rebecca.
So I can think of a couple practical things. It would be interesting, I don't know how feasible this would be, is as part of just the graduate training, every thesis has a chapter that maps out how their work would fit into a pipeline. It may be way down in the foundational knowledge, but then trace it up that this will affect this, which will can be transitioned and da-da-da. Get them thinking about it early on in grad school, thinking about the interconnections, because we're doing system science now. This is just systems, applied systems, really. So that's some of the same skills, but if you can actually get that started, that would help. And if it could be part of the thesis, I think that would be great. Otherwise, I also think the other part of it is to get on teams. If we're moving towards the applied science or the transitional, you're going to need people who work more with that, being the ones that are planning the projects and all, and have the fundamental or traditional scientists there so that they can get experience, so they can come up to speed and become more of a transitional or applied scientist or come up with the projects. But right now, I think it's really important to start pairing, both at a student level and a professional level. And also, once you get into that transitional scientist or the operating system scientist, you really do need to engage with not the end users, but the end user technology, which means the engineers or the technologists that actually create the systems that the end users need. Because often the end users don't know what they need. But you can figure out how the technology systems they're using are susceptible to space weather, and that will provide you the same information. So those are some potential ideas.
Yeah, and I would add, from my perspective, I think it would be helpful, in terms of, classes that are being, taught, in college, if you're thinking about, applied space weather, for example, class where you're actually having, information that, goes down to maybe interested students, as maybe graduate students that are already in that field on how, what they're doing, is impacting the community, or the user need community. And so I think that would be an important one to consider and incentivize. And then also, I think internships where, even if you're studying, basic research or fundamental research type, and, it's important to incentivize students to also work, closely with the industry or user needs, or maybe, internship programs at, SWPC, for example, where they're getting that knowledge on what, how their research ties into, more applied products. Because I think ultimately that will even help them be motivated in their work. And there is multiple reasons I think that would be beneficial from an educational perspective.
Coming from NWP, I can give a real example. I did 7 years providing training of NOAA operational data simulation system to the community. So I can say now, all the candidates applying for NOAA jobs, they have come to the training I provided for those years. And I believe, if the students have opportunities to work with something related to operations, you open the door to connect with that transition, for sure. On the other hand, it also helps to feedback to the research community is what the research community, can help with the operations. And of course, for space weather, you probably don't have as much, but I know Welcome X is a community model. And JEDI is new, but it's going to be open to the community contribution for space weather as well. And using this kind of more community-based but public systems definitely will make it much easier transition to operations down the road. And my colleague just sent a message, ask people to use JEDI. But it is very straightforward for operational people to look at our future work force, and just you have a very limited time to transition to the real operations. And I do think it has been working for NWP world, and it will work for space weather for sure. And Tomoko actually worked with me on the GSI in the past, getting GSI, which is NOAA data simulation system for the space weather. And I believe we should start from there.
I do want to add. Yeah, go ahead. No, I was going to say what you were talking about is also part of why it's taking a team-based approach, and working together is a big part of this grand challenge, because without that, it cannot come together. So thanks for hinting at that. Go ahead.
Yeah, so it strikes me that these problems of transitioning research to some operational or societally useful problem is not unique to space weather, is faced by, I'm sure, any field that has a research community and has some end application. And I wonder, the extent that maybe Hui, you have the most experience here, is our community doing something fundamentally wrong, or are these the same sort of challenges that every community is facing? And there's no like, oh, well, we just kind of follow the pattern that this other group was doing, and we can really get beyond some of these roadblocks, or basically everyone has the same sort of problems in doing this, because it's just hard to do.
R2O is always the challenge, and among the agencies, I always heard that, how to do the R2O. That's why a few years ago, there was some testbed built to provide community support from operational center's point of view. That's for NWP, and I believe it's not really unique for space weather. But after some years, now it's almost 10 years since that effort, I do think I can see the impacts already. So I don't think it's unique, but on the other hand, there's lesson learned from the other community and this community is very close community, very nice, friendly people here. And I think we can do it. We can speed up compare with the other community, just in terms of this smaller group. And I think this is great opportunity for us to talk and start doing something like that.
So I agree with you, but I also think our field has some unique challenges, which is how coupled it is. It is very much a system science. And think of another operational system. Let's say forest fire fighting. So those end users, they want to know when smoke is spotted, so they can use satellite observations. They want to know soil moisture. They want to know vegetation moisture. And so they take all the observations and they bring it into a way, percentage of moisture held in plants or whatever it is, and they have a ConOps, an operating system that says, hey, the risk is really high in this area, or hey, we saw a fire, let's deploy resources there. You look at the technology systems that are affected by space weather, it's not just one thing. Let's take communication, like HF communication. It's neutral density, or not neutral density, ionospheric density structures, scintillation, that sort of thing, E region, D region. Okay, measuring just D region and E region will not give you a forecast. We know that. It depends on all these other drivers. So it's not a single observational source. It's not a single, and then it also depends on frequency of the system you're using. So it's not just the environment, but you have all these other variables of the individual systems. Combining all that for the end user to make, I hate using these words, but actionable decisions is a level of complexity I think our end users that utilize our information have that some other operational users don't. It just means that we have to untangle this whole mess and make sort of sense of it, if that kind of answers your question.
I guess the only thing I'll add is that I'm not sure about maybe implementing models or anything like that from other communities, but one thing I have seen is the earth science community has a lot of very large, valuable databases. And since I use GNSS data, I use their databases with the GNSS receiver. So I think that's certainly a lesson that we could take, that we need real-time data that's being, streamed, and we need, to have it all in one place so it can be easily utilized.
Can I make a further comment? First, I agree that data and also the complex of space weather is much more challenging. I agree. But I want to say is NWP observations not coming suddenly one day you'll have all the observations. They also had the similar problem at the beginning. And also the satellite data most time don't measure temperature, pressure, moisture, the models forecast. They measure radiance. So how that information spread out to models, data simulation for the operator development. And we have very limited people in this community to do that. That's where it can solve the problem. How to use satellite observations, indirect measurement, and have so much content, not just layers. For example, it tells you what layer, that's one measurement, but it tells you something about something happened. The gradient of layers is also very important. How we can use that kind of information? We need science, we need people to dive into data simulation, extract much more information from current observations, even now. So I would advertise that we put efforts, even with the current observations, because we are still using a lot of retrievals, and that's what NWP did many years ago. Retrievals means you have a lot of biases and human beings understanding, so you put it into your data, and that's already bring a lot of errors. And the raw data is better with information, but it takes science to study how to use that. And that's area I would like to look at the community people here to dive in and tell us how we can use observations. Thank you.
Go ahead. Okay.
If it's related, you can go ahead. Mine's off topic.
No, just, okay.
Yeah, I totally agree with what was said now. I don't know any community who will tell you that they have enough data. So I think, yeah, even it's just an example of, well, seismologists, right, or geodesists, they have thousands of GNSS receivers, but this is still the main problem. They do not have enough data. Strong motion, accelerometers, or GNSS receivers to, let's say, constrain the rupture processes of earthquakes. So they will still do, but they still, based on what they have already, they see what they can do and how they can do maximum with what they already have. For example, the early warning tsunami systems or early warning earthquake systems, and see what are the uncertainties with that capabilities they have currently. Yeah, because the more data, the more opportunities you open for yourself to do more research. So this is never-ending, like, wheel, you know. So I think we as a community may also look what we already have and what are the real needs for the specific applications, as was said earlier, and what are these specific applications are, and how much more we need for these applications or other applications. So, yeah.
I have a lot of questions and comments. Can we go back to the slide that had the flow chart on how to go from R to O to R? This works. Okay, so I think my main question is that I'm wondering if we're sitting here in a chicken and egg problem. We're saying, hey, we need more data. It takes a long time to get data. We have models, we have indirect measurements. My question is, how do I get that transitioned into operations now with what we have to get maybe justification on making more data sets? Like we showed that we don't have all of these scientists, we don't have the people with the training, like NOAA has a training program built up to get people to to transition stuff to operational models. We have models, we have measurements, we don't have the people at SWPC to hand stuff off to users. How do we do what we can with what we have right now? How do I get funding to do that? Do I just make an FTP site with model outputs of neutral density? That's my question, yes.
That's a great question. Okay, so I want to make sure that what you see on the screen is a idealistic step from foundational science to end user. To actually solve the problem of going from fundamental understanding to operation, you have to have a multi-prong approach. which means that you may not know what the end user needs. That's more than likely what it is, but you could probably peel back enough to know they care about, I'll go back to HFCOM, they care about density structures. Okay, so you need to be able to characterize or define density structures with improved resolution, accuracy, and so forth. You can start actually defining the problem that I am going to improve our knowledge by 5%, 10% without ever doing that. You can do it saying with the capabilities that we currently have, the operational, but in the meantime, I'm going to try to improve it by 20%, but I am going to do it by using these new tools or doing Aussies to see how much observations do we have to expand to do that. You have to do this in a multi-layer approach, partially because whatever the end user's requirements are right now, it's likely that's not going to be what their requirements are in 3 to 5 years. The technology is moving so fast, their needs are moving so fast. So if you focus on what their needs are right now, by the time you reach their needs, meet them, they're going to be needing a whole bunch more, and you're going to be behind the curve. And I think that was the comment earlier I wanted to make. So even when we talk about something like this, don't try to combine it all in one methodology for tackling research to operations. There has to be multiple paths, which means you're going to have multiple teams of people attacking this problem in different directions.
Let me follow up. I'm wondering, what can I do as a scientist? Do I contact the users myself?
You could, but that will take you a long time.
Exactly. So what I'm asking is, should we look to SWPC for guidance? And should then we say to SWPC, okay, give us your tools, we will improve upon them, hand them back, and then make that the next operational model? Or do we say to NRL or something, because they have a strong user base, as we said, but we can't get their outputs, and the commercial people won't give us that either. So how do we get to start improving the tools that are in place while also doing the fundamental research that we want to do?
You can identify what the operational tools are. They won't tell you what their requirements are. They may not even tell you the data that they're using in the operational tools, but they will tell you potentially. So we know WAM-IPE, we know GlowTech. Those are the models. We know what data is being used in those models right now. So how can we improve on those data sets to improve the output of the models? That's also, a lot of these models rely on drivers like the KPDST. For those models, that's a big source of error. That's not a big source of error in our understanding. We have better models. We have better data sets. Well, how can you create models, tools that run as fast or as simply as what GlowTech or WAM-IPE? If you can show that, if you can develop that, that becomes easy to argue, hey, this is ready for transition. Until you can do that, it can be the best model ever, and an operational user or organization, and I'm going to say Department of Space Force, Air Force, they're not going to look twice at it, because they're not going to want to turn off their operations long enough to replace something with it. They would rather replace their data sources with an improved data sources, improved drivers. They would rather quantify the errors. They would like to improve false flags. But that's for immediate use. The other way is that you engage with people at these institutions who are more of a transitional scientist or an applied scientist. Doesn't mean you have to be the transitional scientist. You just need to get in contact with that person, because you're going to be the expert. You're going to know all the foundational knowledge. They don't, but they need to be able to communicate enough that they know what needs to be brought out of the CEDAR science that is appropriate for operations, and that's the sort of role that you would have, and they can communicate back to you of what is needed.
Who are they?
Sorry.
Are they here? Who?
Sorry. So sorry. I get it. No.
Oh, no, I just was going to add, for example, I work in the industry, and I do know the challenges of being able to tackle that feedback back into the research community. I mean, partly because, a lot of, industry and companies will then take models that are openly available, like TiGCM or WebIP, and hire scientists, and then those scientists will, develop, their own tools, whether that's for orbital prediction. They might have applications in for certain companies, or other tools there. But there is really no incentives for those companies then to feed back that information back to the user, and so the user doesn't really have a way to understand how and what's most important there, and so that is a big challenge, and I don't quite have a good answer to how we can tackle that.
Yeah, I just want to cycle back a little bit to the previous comments. I also feel there is a significant lack of communication, enough communication and personnel exchange between people who are doing fundamental science with people who are more familiar with industry and especially operations. So I think we had this kind of panels even a few years ago at CEDAR at that time, hosted by Zhiwei Fund. So I think at that time I even asked pretty much the same question: is we wanted to contribute, and we don't really know how and talk to whom. Yeah, I think we need to, for the community to really get involved, but we probably need a better and clearer guidance and really a better, also promising direction that we can really do this. And for example, for university to go involved, can we send students to work with you guys? But sometimes there are also restrictions to go to NRL, go to NOAA. It's difficult to send people there. Well, what are the exact efficient way to really push things forward instead of we talking about these similar questions year after year after year? So, yeah.
Just a real practical thing that we can do. We look around here, we have relative to the participants at CEDAR, we have relatively few people in here. And part of it is we need the science community to take an interest in this and to recognize or prioritize the applied science and the transitional science projects and results, whether that means maybe having more presentations like that here, just so that they can start seeing the connections. But they also have to take an interest in it. And you can't force people to communicate. You can try with the internships, but then also the reverse, trying to get more science people at more operational space weather workshop seasons, partially so you can learn how better to present your material to an operational or applied focus. That's where you're going to make some, from the grassroots, some of that connections with these people in those type of roles, and you can start putting these projects together. So that's a practical idea.
I guess I would also say that what you're, the SWPC has the test bed, which I think Hui mentioned also, that many other government research groups also have this as well. And kind of one of the big goals there is to be able to facilitate collaboration and to also sort of test out products before actually implementing them in operation. So that is meant to be an avenue for collaboration. And in terms of, I guess, on a practical level, you can certainly reach out to us at SWPC, particularly if you're writing a proposal. That would kind of be a good time to say, like, hey, I wanted to integrate this into my proposal. Is this something you're interested in? And to kind of start from there. I know that at least I think it was either beginning of this year or last year that NASA had the R to O to R to O to something. Yeah, R to O to R. However many O's and R's there were called. It was kind of specifically focused around that. But and so hopefully if that call comes again, that would be, that's sort of a tailored opportunity for collaborating with SWPC or Space Force or NRL. But it could certainly be integrated into other projects as well.
So I agree with everyone. This is not a one-way effort. This is two-way effort. Right, community reach out, but operational centers, we need to open up as well. And this happens in other community as well. So I agree testbed is one way. Proposal is another way. And also, so NRL is opening up, not opening up our own models, but we are providing proxy models through CEDAR. And so, for example, we talk with Y-X people because I'm just using this as an example. CEDAR is model agnostic. So that means you have schemes you put in there, it can be shared by other models as well. And that's the philosophy, separate concerns. That if you separate each component, you develop observation operators, if it doesn't really rely on specific model interface, then that can be easily transitioned to other models. And if we are, in our development, having that in the mind, that will be very helpful. And of course, if you are using the same system, that will be very helpful as well. So with that in mind, that's why we are going to the community model system, and we are opening up the PyRI, JEDI, HWM, MSys model interfaces, and also Y-X already have model interface through JEDI. So we are providing that platform for people to develop at least for data simulation, your capabilities, and it can be easily used by our operational centers. And I believe having some such thing like this, for NLP, they have this years-long efforts, so-called unified forecast system, including forecast model, including data simulation system. And a lot of it being done is you have this on and off options from different models, like physics, right? We are not there yet, but I do think we are going to that direction, and working on those kind of common platforms will be very helpful. And it needs two sides efforts, of course, but we are getting there.
Yeah, and to that I'll just quickly add, I think it's important, communication is key, and I think like Rebecca was saying, you can engage through participating in meetings like the Space Weather Workshop. But then there is a number of other meetings that, traditionally they don't see a lot of, I would say, CEDAR participation. I'm thinking, for example, about ERSI or many others, where there are companies that are actually present there, or even the Space Symposium. And, you're able to actually get a different audience and communicate and in an informal setting, because that's also important when it comes down to private companies that might not like to share information at a podium like this, but if you approach them, by the hallway, you can actually gather a lot more information that way. So,
I know we need to move on, but I can't resist. I wonder if your definitions of real-time data or near real-time data is the same. Number.
Within 30 minutes.
30 minutes.
Yeah, I believe that's what I heard.
30 minutes, industry?
let's say probably 5 minutes.
5 minutes. All right, on that, I was thinking 24 hours, but I'm stratospheric, so. One last question?
Yeah, it is just a more comment. So what was said before, I ask myself all the time this question, how I'm just a regular scientist can contribute. But it is actually maybe, the communication is not maybe so streamlined, but it is also not so gloomy, because there are specific programs, for example, MURI, right, from NRL or IFRL, who provide the scientists to do fundamental research and demonstrate their capabilities. There are also fundamental research provided, like, DARPA, DITRA, or NGA. So I think there are many opportunities. You just need to maybe be more involved into that process, like working with these guys. Yeah.
All right, everybody, let's thank our panelists. So from my view, we've heard now from several of the runners in the space weather relay race. For the next part of the session, we want to focus on the batons or handoffs. What information needs to move from one sector to the other? Where are those handoffs working well, and where is improvement necessary? And what practical activities could help us strengthen the pipeline over the next few years? At each table, we have facilitators who will help capture the main points of your discussions. And facilitators, I think you're going to be taking notes in some Google Docs. We're going to move on to the group discussions. Yeah, we're looking for concrete ideas, 1 to 3 specific ways to improve the system. We really like to have actionable recommendations, not just a list of problems. So be part of the solution. All right, did you want to say a few words?
Thank you, everyone. So similar to the morning, we have facilitators. Maybe we'll just do 4 groups today. So facilitators, Ling and Hanli, they have a table there. Jian has a table there. Maybe Anna, you can join it. Everyone can move more to the middle and be a little more friendlier so we can have some more conversations. And Federico, you have a table. So if you sit and you can put your hand up and people can join you. And so is Hui. Okay. Thank you. Thank you, Lynn. Thank you for the panel.
Yes.
This was great conversation. I'm sorry to stop the great conversations, but we're getting close to that time, and so then maybe we can go to Jian and Federico and Hui.
Please add up. So I think our table, we started with identifying some of these existing issues. So for example, the user, sometimes they could use the packages and or models, but without sufficient guidance or information from the scientists who are doing the fundamental science. And sometimes they also, we kind of lack of the feedback from users. And then the other point is private companies, they have data, but for profit reasons, they may not share data with the science community. So those are those hiccups over there. And the way we can kind of improve or get things going is maybe we could provide some incentives, try to get both parties together, like writing proposals together, and then on the one way we can have more feedback to each other, and we can kind of like you have the supports and you have same targets. So it's the incentive thing. And also, for example, Murray, Pavel mentioned, is one of the good examples to connect the operational people with the fundamental scientists. And Hui suggested doing the cross-model validations, but more is not just like before we compare things, different discrepancies or similarities across models, is more to really understand probably the fundamental reasons why they have differences or they show similarities, and whether we can summarize some good components out of the model or understanding out of these comparisons and contribute to that to operational people. That's my understanding.
Yeah, because I was reminded that you already had effort to look at different models.
Yeah.
And my point is that if it's a whole model package, and if the operation center doesn't use that model, then your whole work is not going to anywhere, right? That's why I'm saying if we can identify certain scheme methodology coming from that model is somehow giving benefits, that would be much easier transition to operations, because we could adopt that methodology from the research. So not just to look at the whole model package, but rather than look each component somehow scientifically. That will help us to understanding the physics dynamics much more from the operational point of view.
Yeah, those are all great points. And it's nice that you have all the different perspective at the table to come to those conclusions. And so Ling, Hanli, if you had anything to share from your table.
Okay, so since most of people here on our table is from science community, so we talk about for the science community, what is our responsibility is, what we can do. We talked about publishing is not enough, and we recognize that the work required for operationalization of model and observations is very different compared to research. It requires different skill sets and emphasize different aspects. It's a validation, even the validation is very different from science validation. And we identify the importance of a transition community, from research to between research and operation and the user communities. We need a transition. The next is a transition community, and those are different agencies, and we might need to talk to technology people, and we need to be mindful of when we're doing things standardization. For example, even like a data analysis, in my view, data analysis, if you develop a data analysis method, you can be mindful, this is standardizing it so that you can deliver it to the community, something like that, it can be used for other model, for example, things like that. Yes, that's our main discussion area.
Okay. Was there anything else anyone wanted to share?
Is there anything else the table wants to share?
Briefly. So I just want to comment on a theme here I've heard that is we should be transitioning to substandard operational systems as the sort of primary goal. And so I think there's another goal of research systems that actually have more advanced capabilities, using them to demonstrate to the operational centers what they could have if they moved along. And obviously, I'm specifically wedded to ensemble data assimilation, and we've heard people call out JEDI by name. So I have to kind of defend my team, is that DART has a number of more advanced capabilities for nonlinear, non-Gaussian data assimilation than JEDI, but it is not being chosen and operationally blessed. It would be a setback to the operational community to say that we are not going to collaborate or look for handoffs on more advanced data assimilation techniques because we want to standardize. So I just think there is this danger of standardizing at a static point in capability that we need to be careful not to get too ingrained in.
Good point, Jeff.
Quick, maybe related to what Jeff said. I was wondering, maybe a question for Yaga. When you came up with name ASPAD, or when NCAR decided to have this program ASPAD, the P is not prediction; it's predictability. Maybe there's a reason for that, and especially thinking of what Jeff was saying about predictability and prediction this morning. You have a comment on that?
Yeah, I think for two reasons. So having predictability and prediction was too complicated, didn't make a good acronym, and partly because NCAR is not an operational center. So that's why prediction is often more goes with the operational centers, and research on predictability goes with a research center just broadly, but obviously the two go together. So we just chose the P that was more appropriate, but really both could have been in there.
Good question, Hanli.
I have one more comment, just as we touch on how we are choosing how to move forward, is to be respectful for the people outside of NCAR. I know this is a concern, but I would just like to further voice it. There are some models you can't run on non-NCAR supercomputers, and there are some times you can't download the restart files if you don't have access to the NCAR supercomputer, which is something you can get, but not necessarily always as a non-US citizen.
Yeah.
And being inclusive and recognizing that, and recognizing the barrier that NCAR can pose to non-NCAR people. Not saying anything bad about NCAR, not saying anything like that, but just we need to be mindful of how accessible everything is going to be to everyone as we move forward in this development.
No, that's a great point. And we know that some of our models are difficult to run, expensive, and we are working in trying to find what are ways could we run things and make the data available, or we've had teams that have gone to different locations in the world. I know it was Ethiopia or somewhere in Africa a couple of years ago to do training, but still those barriers are there. You're right. And Yaga, did you want to say something?
Yeah, we do have a new data platform. It's called GDEX, Geoscience Data Exchange. So I think that is partly removing some of those barriers, but not all. So sometimes if something is a barrier, just let us know and we can try to fix it. We're struggling with that for other activities, for like subseasonal prediction. How do we get data from NASA, NOAA, and everything? So what we're starting to do is actually get the data all onto GDEX in a common format and just removing the barrier for access to GDEX. Obviously, it depends how big, what are the models, et cetera. But it's definitely on our mind, especially how you deal with like models from NASA and what does that run. And so that is part of the struggles.
Yeah.
But the more we know, and the easiest often way is to make you a collaborator, and then you get an account on the computer. So sometimes we do need to just go that extra route. Yeah, there are some countries that are restricted, but often we just would have to. I don't know, what country are you from? Oh, okay. Well, I mean, there are a few countries that we, for political reasons, we can't, but for majority we can, and we just make them collaborators, and then they get an account on the system, and often we will, like, just for analysis, add them to our own accounts, so for people who do really want it closely. It's not ideal, but we do it.
Discussing the in-car computing. It is a resource for graduates. You're not a graduate student anymore, but graduate students can get small allocations on the in-car computer, so you should keep that in mind and share with your friends. Okay, that's news to me.
That's new.
But anyway, we can maybe have a
I know there are, but I'm just.
But that's
it is complicated.
that should be at least kept in mind that for students or
I
whatever.
recognize it's doable, but we should not make it machine specific. Yeah.
Yeah.
So, I think Hanli said something. Hanli said several times. Noticed at least 2 times. That P is a predictability, not prediction. I think I agree. I think we, as a science community, I think we stay on track of predictability. We work on predictability, and that's what we can do the most. It's not the prediction. And by doing addressing the predictability, we are moving closer to the prediction side. I think, yes, I think we stay on track of addressing predictability.
Yeah, yeah, you said
Yeah.
it well, Ling. And
I wonder how many people understand the difference.
not many.
Prediction.
No, I just want to say, yes, we understand the difference now, but outside of our community or even this room, how many people understand the difference?
Yeah.
And should they understand?
Yeah, but they do get confused and used, yeah. Yeah, okay, because we only have, well, we're already over time, Yaga, but we have, first I want to thank you for staying and engaging in the conversations. It was 2 hours, so really appreciate that. And then I'm going to hand it over to Yaga for closing remarks and some next steps of how we're going to move forward with this grand challenge.
Yeah, so thank you all for coming, and thank you all for participating. And I think we have just one more slide. So as a follow-up, if you haven't done already, sign the name sheet. I think Suda still has it. And she's also going to send out a follow-up email just asking you whether you're interested in participate in the working groups we're going to try to form. So in July, Suda is going to take all the Google Docs and synthesize all of the information that has come in, and we'll see if it makes sense to divide into different working groups. We're going to do it by the science question. And we would hope to have some people participate and some people volunteer to co-lead the groups, and also start thinking of suggesting deliverables and what is needed for those groups to go forward. And we're thinking of kicking them off in early September. The questionnaire is also going to ask you whether you're going to AGU or AMS, so we can have another meeting point and do something there like a common lunch with some presentations, etc. If there's a lot of people, we can have a side meeting the day before. So those are the things we're thinking, and just to continue the conversations in between. So for the working groups, we're thinking they usually meet every 4 to 6 weeks, and then we have these in-person meetings with CEDAR and AGU, AMS as appropriate. So again, thank you so much for joining, and reach out to me with any questions, or Suda, or Hanli, or anybody who's been here. So thank you again. Have a great afternoon.